All right, part C.
Okay.
So here's what I'm going to do. And we'll write 835 up here so we don't forget it.
Yeah.
All right, so I'm going to take 2005 and find the number of numbers that are divisible by 3. So I'm just going to divide 2005 by 3.
Yeah.
Okay, so I get, let's see, 600? 18, 6. 3 goes into 25.
That would be, it's 8.
Okay, so I get 668. There's 668 multiples of 3 less than 2005.
Okay.
There's a remainder of 1, but that's okay. Now I'll do the same thing dividing by 4. Do you see a quick way to figure out what 2005 divided by 4 is?
Well, 2000 is divisible by 4.
Yeah, what is 2000 divided by 4?
1000 divided by 4 is, so it's 250.
Uh-huh.
It's 250 times 4, so, and then 250 plus 1 because of that, and then 250, so we get 251.
Well, I think 1000 divided by 4 is actually 250.
So that means 500 times 4 is 2000.
Yeah, so that's 100. 500 times 4 is 2000.
Sounds right.
Okay.
So then we add, so it's 500 then plus 1.
501.
501.
So we got 668 multiples of 3, we got 501 multiples of 4.
Yep.
And now we got to figure out how many multiples of 12 there are. So 2005 divided by 12. Oh, you already did that. It was 167, right?
Yeah.
Now we got to think about something here. You ever heard of a Venn diagram before?
Yeah.
Okay, so here's all of our numbers. So 2005
So I,
numbers. And in the multiples of 3, we had 668.
yeah.
And then in the multiples of 4, we had 501. And then in here, it turned out there were 167 in the overlap, because multiples of 12 are multiples of 3 and multiples of 4.
Yeah.
So if I add these two together, how many times did I add the multiples of 12? How many times did I count every multiple of 12?
You counted it, I think you counted it twice.
Okay, so how many times do I have to subtract 167?
Twice.
Twice. That's pretty interesting.
Yeah.
Remember when you did your list, 3, 6, 9, 12, 4, 8, 12, you wrote down 12 twice?
Yeah. So
I gotta subtract it twice. So I gotta do 668 plus 501, which is what?
well, it's 1169.
1169, and then I gotta subtract away 167.
So we got 1002.
And then I gotta subtract 167 again.
So it's, then we got, so 900 minus 60, so we get 840, then minus 5, so we get 835. So we got the same answer.
Look at that.
Cool.
Hey,
35.
that's awesome.
65.
Two totally different ways, it seems, huh?
Yeah.
So I like your idea of breaking it up into a small case. And here, it's important to recognize that 12, the numbers from 1 to 12, form a nice case, because then we gotta pay attention to that 12.
Yeah.
And in my way of doing it, the tricky thing is that you do this Venn diagram and realize you counted the overlap twice. You counted that multiples of 12 once with the multiples of 3 and once with the multiples of 4.
Cool.
So then we gotta subtract those away
Yeah.
and subtract them away twice, and we get 835.
Yeah.
All right. Good job.
Mm.
Just the marker cap in my pocket. That's a cool problem.
Yeah.
That's a very challenging problem too. I like that one though.